Welcome everyone to EET 261, Communications Electronics. I'd like to go over your Chapter 2 homework. Problem 1, what is the gain of an amplifier with an output of 1.5 volts and an input of 30 microvolts? Expression for gain AV is going to be equal to V out divided by V in. Please always remember to convert back to base units. So 15 divided by 30 microvolts, 30 times 10 to the minus 6, gives us a gain of 50,000 or 50K. Question 2, what is the attenuation of a voltage divider circuit like shown in figure 2-3 of our text, where R1 is 3.3 k ohms and R2 is 5.1 k ohms? Using voltage divider expression, R2 divided by R1 plus R2, plug in the numbers and we will get an overall attenuation of 0.607. Question 7. A power amplifier has an output of 200 watts and an input of 8 watts. What is the power gain in dB? Power gain, A sub P, is equal to 10 times the log of the ratio of the powers, P out divided by P in. We plug the numbers in. Overall gain is going to be 13.98 dB. Question 8. A power amplifier has a gain of 55 dB. The input power is 600 milliwatts. In this example, what is the output power? So again, power gain, A sub P, is going to be equal to 10 times the log of P out over P in. So we're going to algebraically manipulate this expression, solving for P out. When we take the inverse log of both sides of this expression and rearrange, we're going to get output power is 189,763 watts. Question 9. An amplifier has an output of 5 watts. What is its gain in dBm? So please remember, dBm is simply we are referencing our power to 1 milliwatt unit. So AP and dBm is going to be equal to 10 times the log of P out over P in. Again, reference to 1 milliwatt. Plug the numbers in, 36.9 dBm. Question 10. Communication system has 5 stages with gains and attenuations of 12, minus 45, 68, minus 31, and 9 dBs respectively. What is the overall gain? Since they are already expressed as dBs, we can simply add these together. Overall gain is going to be 13 dB. Question number 11. What is the reactance of a 7 picofarad capacitor at 2 gigahertz? So capacitive reactance, X sub C, is equal to 1 divided by 2 pi times the frequency times the value of the capacitance. Plug these numbers in. We will get an overall capacitive reactance of 11.37 ohms. Question 12. What value of capacitance is required to produce 50 ohms of capacitive reactance at a frequency of 450 megahertz? This time we're going to rearrange that expression, solving for C. When I plug the numbers in, I should get 7.07 picofarad. Question number 21. What circuit Q is required to give a bandwidth of 36 megahertz at a frequency of 4 gigahertz? So the expression for Q is equal to the resonant frequency divided by bandwidth. Always remember, convert back to base units. Overall Q for this circuit will be 111.1. And the last question, question 22. Find the impedance of a parallel resonant circuit with values listed. The inductor is 60 microhenries, the resistor is 7 ohms, and the capacitor is 22 picofarad. So we have our parallel RLC circuit. Remember, at resonance, the inductive reactance is equal to the capacitive reactance. So I algebraically solve for this expression. Ultimately, I'm looking for resonant frequency, where resonant frequency is equal to 1 divided by 2 pi multiplied by the square root of LC. Plug these numbers in. I'm going to get a resonant frequency of 4.38 megahertz. At resonance, the value of resistance disappears, so the equivalent impedance of this circuit, Z1 times Z2, divided by Z1 times Z2, I plug those numbers in. I should get an overall impedance of 389 k ohms. Thank you.